quadratic formula, so we'll get into that in a minute. But I want to remind you, you got your quest 3 back on Monday, and I'm going to allow you for this one quest to make corrections and get up to half of the points you missed back. And that is going to be due the next time I see you, which isn't until a week from today. Okay, so there's no classes Friday, there's no classes Monday. So a week from today, April 22nd, your quest corrections are due. I'll be in the math studio tomorrow. And Tuesday I have office hours, so you'll have access to the math studio and my office hours between now and when they're due, even though we don't have class. All right, so don't forget test corrections. I handed out some blank quest 3s. If you didn't get one, ask me after class. I'll get you one. All right, so that's it for administrative stuff. Okay, so today we're going to learn how to use the quadratic formula to solve quadratic equations. So this demo is a little bit long, so you're going to have to bear with me here. Here I've got 4 graphs, A, B, C, and D, right? Of 4 different parabolas. And this is what we learned how to do last class. We were graphing parabolas. Okay. So I want to state the number of x-intercepts and estimate the coordinates of the x-intercepts. So for this graph A, how many x-intercepts does it have? 2. And what are their coordinates? Yeah, but if I ask for the coordinates of a point, there's actually 2 coordinates and an x and a y. -6, 0. -6, 0. And the other one is at 1, 0. Good. All right, how about for graph B? How many x-intercepts does it have? 1. It just touches the x-axis and then turns back around. So it's got 1 x-intercept. What are its coordinates? 2, 0. Graph C, how many x-intercepts? 2, right here and right here. And this first one, what does it look like the coordinates are there? -3.5-ish, 0. And then my other one, what does that look like? 1.5-ish. We have to estimate those because they don't go through the nice grid points. And then how about this last one? How many x-intercepts? 0. There are none. Not applicable. Can't give coordinates if they don't exist. All right. So you can have 0, 1, or 2 x-intercepts for a parabola. And those are all the possibilities. 0, 1, or 2 for any parabola. All right. So here I've got graph A. Repeat, I just drew it again here. It represents the parabola for the quadratic equation y equals x squared plus 5x minus 6. The 2 x-intercepts we already determined were at -6, 0 and at 1, 0. Using the graph, what would the solutions be if I wanted to solve x squared plus 5x minus 6 equals 0? What would my answers be? -6 and 1. Yeah, -6 and 1. Because what I did is in my equation, y equals x squared plus 5x minus 6, I replaced the y with a 0. So I'm looking for points on that graph that have a y coordinate of 0. Oh, look, I wrote 2 down, right? These 2 points are on the graph, and they have y coordinates of 0. So my x values are -6 and 0. And 1. All right, but how could I have found those solutions algebraically? If I didn't have a graph to look at and I wanted to find -6 and 1, I wanted to find the places where x squared plus 5x minus 6 equals 0 algebraically. So what we would do is we would try to factor the x squared plus 5x minus 6. And you could do that with a box, or you could use a double bubble, right? So we would have 0 equals... Can anybody do the factorization in their head yet? X plus 6, x minus 1. Yeah. If you still need the box, great. Yeah, keep doing the box. I'm not going to go through it now just for the sake of moving along, but you would get this factorization by doing the box, right? So then I have a product of factors and the answer is 0. I'm multiplying two things together and the answer is 0. The only way you can get the answer to a multiplication problem to be 0 is if one or both of your factors is 0. So that means that either x plus 6 equals 0 and or x minus 1 equals 0. And then you have to solve these two equations separately. So x equals negative 6, subtract 6 from both sides, x equals 1. And those are the values that we read off of the graph. All right, let's see if we can do the same thing with graph C. I graphed a parabola. It's y equals x squared plus 2x minus 5. My x-intercepts, we said, were at about negative 3.5 and 1.5. I actually tweaked it. I think it's more like negative 3.4 and 1.4, whatever. All right, so using the graph, I want to find places where x squared plus 2x minus 5 equals 0. What would those x values be according to the graph? Negative 3.4 and 1.4. Right? Because in my equation y equals x squared plus 2x minus 5, I replaced the y with a 0. Right? I replaced the y with a 0. So I'm looking for points on the parabola that have a y coordinate of 0. That would be these two. The x values are negative 3.4 and 1.4. Okay, but I cannot find solutions to the quadratic equation x squared plus 2x minus 5 equals 0 because it is impossible to factor x squared plus 2x minus 5. If I try to do the 2 by 2 box, it just doesn't work. Not factorable. So what do you do when something is not factorable? The quadratic formula. So the quadratic formula says that if you have an equation that looks like ax squared plus bx plus c equals 0, and it has to look exactly like this, something times x squared plus something times x plus something else equals 0, then its solutions can be found using this formula. All you have to do is plug in the a, b, and c into this formula, and you'll get the answer. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So keep in mind that the symbol plus or minus used in the quadratic formula is combining two equations into one. It means that the quadratic formula has two solutions, negative b plus the square root of b squared minus 4ac all over 2a, and x equals negative b minus the square root of b squared minus 4ac all over 2a. So we use the plus or minus just to save ourselves from having to write that twice. I know, yeah. You should try to memorize the quadratic formula. If you go on YouTube, you can find people singing it to the tune of Pop Goes the Weasel. I will not do a rendition for you. It would not be pleasant for anyone. Okay, so let's try using the quadratic formula. We've got x squared plus 2x minus 5 equals 0. So if necessary, we first have to manipulate it so it looks like this. Does it look like something times x squared plus something times x plus something else equals 0? Yeah. I've got an x squared term, an x term, and a constant term, and I have 0 on the other side. So I'm all set with step 1. One side has to be 0. All right, now I have to identify and write down the values of a, b, and c. So what is the number glued to the x squared, right in front of the x squared? 1. There's a little hiding 1 times there, 1 times x squared. So a is 1. What number is right in front of the x? 2. And then what's my constant term, the negative 5? Okay, so I have values for a, b, and c. Now I have to plug them into the quadratic formula. So I've got the quadratic formula written down here. And as I plug these numbers in, I'm going to be really, really meticulous about every time I put in a number instead of a letter. I'm going to put parentheses around the number because this will help me keep the negative signs straight, because what's confusing about these problems is negative signs. So x equals, I'm copying this formula step by step, symbol by symbol, replacing each letter with the number. So I've got a negative sign. And then I want to put in, instead of a b, I want to put in the number that b is, which is 2. And I'm going to put a parentheses around it. Always going to put parentheses when I replace a letter with a number. Then I'm just going to continue copying the formula, plus or minus the square root. All right, then I have b squared. So I'm going to put in 2 squared. And I'm putting parentheses around the 2. Every time I put in a number, put parentheses around it. Next symbol is a subtraction sign. Then a 4. Always use 4. Yep. And then I'm going to put in my a value. What is a? 1, parentheses 1, times c. So I put in parentheses -5. Replace the c with a -5. Nope, I'm going to put parentheses around each number that I plug in. Each number that I plug in, when you put it in, you put parentheses around it. And then this is going to be all divided by 2 times my a value, which is 1. And then here, I'm going to caution you to try to not do too much at a time when you simplify this. So now my goal is just to simplify this ugliness. And I'm just going to do a little bit at a time. So I've got -2 plus or minus the square root. All right, what's 2 squared? 4. And now I've got -4 times 1 times -5. Comes out to plus 20. That can be very confusing. You've got a subtraction sign and a negative sign. Think of that as doing -4 times 1 times -5. So in this case, it comes out as plus 20. And then this is all over 2 times 1, which is 2.
Simplify that.
Yep, I am just trying to not do too many simplification steps at once, so I won't make a mistake. So I'm not done yet. Next step, I'm going to simplify 4 plus 20 to 24. And negative with 2 in parentheses is just a -2, so I can drop those parentheses now. Plus or minus the square root of 24 all over 2. All right, then how do I finish simplifying this? What's the last thing I got to do?
Simplify it, just run the equation. And...
No calculators yet. No calculators yet. The square root of 24 can be simplified, right? Does 24 have any perfect square factors? 6 and 4. So I'm going to rewrite my 24 as 4 times 6. And then the square root of 4 is 2, so I'm going to bring it outside the radical and make it a 2. So this is -2 plus or minus 2 root 6 over 2. And then you can break this into 2 fractions, -2 over 2 plus or minus 2 root 6 over 2. And finally, reduce your 2 fractions. What is -2 over 2? -1. Again, so those canceled. Then I have a 2 over 2 here. Those cancel. So I have plus or minus square root 6. Right, right. Oh, you were thinking of 9. Yeah. So those are our solutions. -1 plus or minus root 6. Okay. Which is shorthand for 2 different solutions, -1 plus square root 6 and -1 minus square root 6. Those are the exact solutions. If I want to get a decimal approximation, I have to type those things into a calculator. And I'm going to make sure that you all have practice doing this on the kind of calculator that you're allowed to use on the test. So I'm going to hand out some calculators right now. Okay, so I have a different calculator that I can project up here, but it works very similarly to yours. The buttons are just in different places, right? So here's my calculator. I want to type in -1 plus the square root of 6. So I've got a negative button, right? So I do -1 plus, and my square root button is a second. Yours might be also, or you might have your own special button. So I do second square root 6. hit enter, and you get about 1.449. And then you should also do -1 minus square root 6, and you should get about -3.449. I am going to pause and come around and check if anybody needs help with their own calculator. Okay, so we can type in -1 plus root 6 and -1 minus root 6. So you have to be really careful, particularly in my math lab, to read the directions carefully. When they ask you to give an exact answer, that means they want the radical, right? They want the -1 plus root 6 and -1 minus root 6. That is what's called the exact answer. If they ask for an approximate answer, or approximated to blank blank decimal places, however many decimal places, that means type this into your calculator and give these two numbers. Okay. So be careful whether they ask for an exact or an approximate. Exact is the one that has the radical in it.
Well, they want it printed like that. They don't want it.
Right. If they ask for an exact value, they want you to type in with a radical. Just leave it alone. Yes, Chantal. Yeah, they'll usually ask for both, and they'll often say write them in smallest to biggest or something like that.
Well, if you get it wrong, you're going to know that you made a mistake.
Yeah, right. Okay, so one other thing I want to show you with the calculator. Often you'll be unable to simplify. So we got -2 plus or minus root 24 over 2, and that simplified. But if that radical 24 could not be simplified any further, then this would have been our answer. So we need to make sure we can type this kind of thing into the calculator also. So I would do, if it were me, I would type in -2 plus the square root of 24, and then I'd hit enter, right? Because there are imaginary parentheses around any numerator when you have a fraction. If right now I just did over 2, it's only going to do radical 24 divided by 2, and then it's going to add the rest of it. I could put another set of parentheses if I wanted to type it all at once, yeah. So I could put parentheses around my whole numerator, right? So that means it would do the whole numerator and then divide by 2. Yep. So that gives me the 1.449. Or I could also break it into 2 steps. I could do -2. This time I'm going to do the minus. -2 minus square root 24. And then divide by 2, and you get the -3.449. So you can do whichever way you like. The calculators that I lend you for quests and tests, or that you have, do have parentheses. So you could do it all in one step if you want. All right, so take a couple minutes. Make sure you can get this to come out by typing in -2 plus or minus radical 24 over 2. Okay, so moving on. Here I have a quadratic formula, a quadratic equation. I have a quadratic equation, but it's got fractions. Like, oh no. What do we do? How do we clear the fractions? I'm going to multiply every term on both sides by 3. Right, I'm going to multiply the whole left side of the equation by 3 and the whole right side of the equation by 3. And I got to distribute, right? 3 times 2x squared, what is that? 6x squared. And then I have to do 3 times 7/3. What is that? 7x. Yeah. And then on the other side of the equation, I have 1 times 3, which is 3. Okay. Am I ready to apply the quadratic formula? Why not? I need one side to be 0 to use the quadratic formula. So the first thing I have to do is subtract 3 from both sides. Okay. Yeah, I multiplied 3 times 7/3, and that gave me 7. Yep, and there's an x there. Okay, so now I have a new quadratic equation, a new equivalent quadratic equation. Now I can apply the quadratic formula. What is my value of A? 6. What is my value of B? What is the value of C? -3. Then I can plug into the quadratic formula. X equals the opposite of B, plus or minus the square root of b squared minus 4ac all over 2a. Right, so the opposite of b. So I'm going to copy my formula symbol by symbol, and every time I put in a number, put parentheses around it. So I'm going to have negative parentheses 7 plus or minus the square root of b squared. So I'm putting in a 7 for b. I'm going to square it. Minus 4 times a, which is 6, times c, which is negative 3. All over 2 times 6. So every time you put in a number, replace one of those letters with a number, put parentheses around it. And then we just simplify. Now it's just a matter of arithmetic. So I get x equals negative 7 becomes negative 7. What is 7 squared? What is negative 4 times 6 times negative 3? Yeah, it's negative 4 times 6 times negative 3. So I have a negative times a positive times a negative. That's going to become positive. And 4 times 6 is 24 times 3 is 72. All over 2 times 6, which is 12. All right, and then what is 49 plus 72? 121. So this is negative 7 plus or minus, that's not quite enough room. X equals negative 7 plus or minus the square root of 121 over 12. Yeah, the square root of 121 is 11. So instead of writing square root of 121, I'm going to write 11. So this, yeah, this actually means negative 7 plus 11 over 12, or negative 7 minus 11 over 12. And then I can calculate these, right? 11 minus 7 is 4, and 4 over 12 is 1/3. And then negative 7 minus 11 is negative 18. Negative 18 over 12. Yep, negative 3/2. Yes. If b is already negative, this is a really good question, so people might want to listen. If b is already negative, when you plug into here, you'll copy the negative sign from the formula, and then within the parentheses you would have put a negative 7, and then it would say negative negative 7, and it would turn positive. You can jump right to that positive if you see it, but do the parentheses things will always help you keep the sign straight. All right, any questions on this calculation we just did? Yeah. Very top? Sure.